When it comes to understanding the cloud, it's obviously essential that we have a shared definition, what I'm thinking and what I want you to be thinking when you think of the cloud. So we're going to start out right here in this episode with a solid definition of what a cloud actually is. And we're going to derive this definition from the NIST 5. They define 5 characteristics of cloud technology. And so let's begin by looking at this definition. So it says, the cloud may be defined as the on-demand, self-service access to computing resources that are pooled and broadly available for network access, providing rapid elasticity and measured use. So this thing we call the cloud, first of all, is defined as on-demand self-service. This means that you can go and get something when you want it. Now, what is this something? Well, it's the typical things you're used to thinking of being on your network. So you want a server, you can get one on demand. You want a network router configuration, you can get one on demand. You want a DNS server, you can get one on demand. You want a database, you can get one on demand. You want AI, you can get it on demand. All of this is just in the cloud waiting for you to say, enable this in my cloud account and let me begin to use this. So that's this concept of it being on-demand self-service. The next parameter is computing resources. And so the things you can get on demand are, of course, computing resources. And that means computing processing. And it also means memory. It means storage. It means everything you would think of as using within a computer. And then we have the fact that they are pooled. Now, what it means for them to be pooled is that you're getting the most efficient use out of your entire collection of hardware as you possibly can. Now, you'll see why I'm saying it that way as I get toward the end of this definition. The hardware I'm talking about may be the cloud, it may be yours, but the point is it's pooled. So it's the concept of multi-tenancy. So multiple different tenants or subscribers or users of this pool of resources. And then it's also going to be broadly available, meaning wherever you're at on the internet or in the world, it's available to you. So you can gain access to it. Most cloud providers do this based on what are called regions and availability zones. So they're in regions of the world, and then within regions of the world, they have different data centers that are available to their subscribers. And then finally, it provides rapid elasticity and measured use. Rapid elasticity means it can grow and shrink as you need it to. And measured use means that you can monitor and measure how it's being utilized. Now, what did I mean by you'll understand why I talk about computing resources as possibly your collection of computing resources? The issue is you don't have to run someone else's cloud. You can run your own cloud. And in fact, many organizations do. There are open source solutions that allow you to put a layer over top of things like VMware, ESX, and Microsoft Hyper-V so that you can implement on-demand self-service access to computing resources that are pooled and broadly available and are elastic in nature and, of course, can be measured. So all of that can be done with your own computing resources. You can build a few racks of servers. Maybe you've got 10 servers in a rack, so you've got 30 total servers, but you might be running 120 virtual servers across those 30 servers in your private cloud. So how did all of this happen? Well, the cloud evolved on us. It didn't just happen to us. We started out with, of course, our own networks, right? We had our networks with our client computers and our network infrastructure and then our servers. And every server was a single server running an operating system, and then it might run multiple services, but it was one operating system instance. It was one host on the network. The next step in the evolution was, hey, what if we plug in a virtualization layer in between our operating systems and our hardware? And so what this allowed us to do was say, well, now we've only got 2 physical servers, each running virtualization layers, and our 5 servers in this case are spread across those 2 physical servers. The next step was to say, what if we take all of that and put it on someone else's network, aka the cloud? And then all that's left on our network is our network infrastructure and our client devices. And we go across the internet pipeline, our internet service provider, to get to the cloud for all of our servers. Someone else is virtualizing. Someone else is implementing a large-scale network and data centers and all the cooling and the power supply and everything that's required for that. So that's how cloud came along to us over time. Now, there are large cloud providers. These include AWS from Amazon, Microsoft Azure, Google Cloud Platform or GCP, and there are emerging providers that are coming on the scene really every day.